So today my topics of sharing will be Miyawaki steam trap and Chlorus temperature control. So on Miyawaki steam trap, I actually have these outlines. I mean the topics that we will cover today. Introducing of what is a steam trap, what is the classification of steam trap, and then I will also introduce Miyawaki SCCV because this SCCV is a system on that actually implied on the design of a Miyawaki steam trap. And of course, the types of steam trap that we have, I will cover also on the how it works, how the working principle of thermodynamic steam trap, mechanical steam trap, thermostatic steam trap, and how we do selection of steam trap. And of course, I will on the final of this sharing, I will show some pictures or images of typical installation of our Miyawaki steam taps on our customer sites. Yeah. So before we begin, steam trap. So what is the purpose of steam trap? So because steam trap, as the name implies, is very straightforward. It's a device used to discharge, condensate, and non-condensable gases with negligible loss of steam. So all Miyawaki traps can open, close, or modulate automatically. So this statement here actually show that our traps is actually all doesn't have any actuators on it. So it's actually based on a mechanical reaction, changes of temperature. Later on, I will go on that parts. So mostly you can find the steam trap in steam pipes and modulating heat exchanger. Yeah. So before we move on, so everyone also know that steam. What is the usage of steam? So why is steam is actually generated and how it's being used? Because steam work as an energy storage and transfer. So steam as a medium to transfer the energy. So what energy is actually being stored in this steam is actually heat. So this heat is actually mostly used to heat up products to a certain temperature. So this is the usage of steam in the production line or in the process line. And how is condensate formed? Because during this sharing session, I will keep on mentioning about steam and condensate. So just now I talked about the usage already and what is steam trap already. So what is condensate? Condensate is a form as steam loses the energy, because steam is actually a medium that carry the heat as a energy. So once the heat has been discharged in the process of transferring energy to the products, then the condensate will be formed. So condensate normally we will call it as a liquids or water in this form. So today, the classification of steam trap, we actually have three types here. We will have thermodynamics, and then the thermodynamics actually represent a representative model. We call it this type, or we call it it's a thermodynamic types, TD trap. Yeah, the operation principle for this, as the name implies, thermodynamics. Thermo stand for temperature. Yeah, it's related to temperature, and then dynamic is related to speed or velocity. Yeah. So the operation principle will be a relationship between the velocity and pressure exerted by steam and condensate. The changes of velocity and pressure will actually make the steam trap open and close. Yeah. And then we have this mechanical type of steam trap. So this mechanical type of steam trap actually have two models here. You can see my cursor here. Yeah. So the representative model is a float type, or we call it a ball float type, and a bucket type, inverted bucket type. Yes. So the operation principle for this mechanical types of steam trap actually by using the difference in density between of steam and condensate. Yeah, density, because density is like more to the weight of the mediums. So because steam is like lighter, and then condensate water will have a higher density, which is much heavier. Yeah. And of course, the last type would be thermostatic. Thermostatic is just like the name impose as well. Thermo for temperature. Static is that static is a movement. Static, it doesn't move. Yeah. So this thermostatic is actually operate on temperature difference between steam and condensate. So from these three type here, actually you can see a difference of operation principle. So these three types of different operation actually give a different result on how the process go on for the discharging of a condensate. So before I move on, so I will introduce a system from MIYAWAKI, also known as a SCCV system. So this SCCV system is worldwide patented by this MIYAWAKI. So later on, I will go on how this SCCV works and how does it affect on how does it implies in the MIYAWAKI steam trap design. So what is the SCCV system? So SCCV system is a self-closing and centering valve system. It is international patented by MIYAWAKI, and it is mainly adapted in MIYAWAKI inverted bucket, bowl float, and temperature control steam trap. So you can see this SCCV is actually adopted in many of steam trap design in MIYAWAKI. So later on, when I go on, I will go on about how is this design actually the MIYAWAKI steam trap benefit from this SCCV system. So what is about this SCCV system? So this is actually an image to show how this SCCV system works, yeah, how it actually works in nature, yeah, how it works. So we can see in this picture here, this basin here, yeah, and then it's filled with water, and then this plug attached to this chain over here. So you see this water is actually flowing out through this suction force generated by this opening here, yeah, because of difference of pressure, yeah, the pressure inside here and pressure outside here will create this suction force. So during this suction of liquid going out from this basin, this plug actually will happen to suck in to this to close position of this basin, to close the whole system, the basin to stop from discharging all the liquid from out of this basin, yeah. So later on we will go on about the how this actually implies in the MIYAWAKI steam trap design. So this is an example of MIYAWAKI bowl float steam trap internal parts. Later on I will go on to this MIYAWAKI, but this is like an introduction. So later on I will discuss on this one. So you can see this one is actually in our inverter bucket, bowl float trap, temperature control valve, as I mentioned previously, yeah. Different types of temperature control valve also implement this design of SCCV on the valve closing